my friends, let's start a series of classes on what we term as your what limit. Now, we're going to, it's a long class, and after limit, we'll go straight to differentiation. Now, let's go into limits. This will be our lesson 1, of course. So let's start. Let's introduce the term limit. The question is, what is limit? I'll start by the word that the limit L is the value of f of s as x approaches a. Now, come now. The limit L is the value of f of s. Now, let's give a statement that this limit L is the value of f of s as s approaches a. The value of f of s as s approaches a is the limit L. So if they ask you what's the limit, you tell them that the limit L is the value of f of x as x approaches a. So the limit L is the value of f of s as x approaches a. For one more time, what's the limit L? The limit L is the value of f of s as s approaches a. That's just the definition, very short. It means that as x approaches, let's say for example, now, and this number, let's say this number here is 4. And let's say this function is 2x, let's say 2x plus 1, and it's equal to 5. And let's say lim as x approaches 2. Now, if you put 2 here, you're going to get 5. Now, what we are trying to say is that as we are approaching 2, we are getting closer to 5. Do you understand? So just know that the limit L is the value of f as s approaches. So we're going to explain that. Now, if you say you understand that, what are the laws of limits? Now, the laws of limit are just what we need to know about. I'll tell you how to use them, but we may not practically use them because we'll solve questions without these laws. But let's just learn the laws of limit. Now, if f of x is equal to L, and that limit, lim g of x is equal to m as s approaches a. The first limit says that the sum of limits is the limit of the sum. That means if we have lim g of x plus lim f of s plus g of s as s approaches a, it's the same thing as saying you focus on them individually, that lim f of s plus lim g of x as s approaches a is equal to what? L plus m, where L are their numbers. So very simple. What the law says that the sum of the limit is the limit of the sum. Now, let's see law 2. Law 2 said that the difference of the limit is the difference of the limit is the difference of the limit. That means if we have f of s and g of s, we are asked to separate them. We can break them individually and have lim f of s minus lim g of s. Or you carry their answer and say lim L minus lim m. Just where we have the sum of limit is this sum of the limit is the limit of their sum. The difference of the limit is the difference of the limit. Are you seeing that? Now let's see law 3. We'll talk about your constant. What if you have a limit multiplied by a constant? Lim c of f of x is equal to the constant times the whole limit, and which is equal to, if this is the answer times the constant. Do you understand? Now these laws, like I said, may not really have a conspicuous use, but we're going to learn how to solve. The main thing is that can you solve a limit question? So I'm going to still show you how to use these laws. Now let's see. Hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app, and then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you are going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Man, this semester, you must do well. Anyway, let's proceed quickly as we march down to our class and continue our class. Enjoy. The next law we say f of x and g of s. Let's see our law 4. Law 4 is just the product. Just the way we have the product of the limit is the limit of the product. Are you seeing that? So if you have lim f of x and g of s, and we have lim, it is equal to lim g of s times lim f of x, or you say L times m. So the product of the limit is the limit of the what of the product. As well as quotient, if you have lim f of s over g of s, this is the same thing as saying lim f of s all over lim g of x as s approaches a, or you say L over m, provided the denominator not equal to 0. We said that in math, the denominator must not be equal to 0, because if the denominator is equal to 0, it is practically called a what? Mass error. Do you understand? So the lim of the product is the product of the limit. Now, the sixth thing we're going to talk about is the power. So if we have lim f of s as s approaches n, this is lim f of s raised to power n as s approaches what a, or l raised to power what n, where n is a positive what integer. And the last but not the least, talk about the roots. So if you have square root of lim f of s, it's the same thing as lim f of s all raised to power root. Are you seeing that? The root of a limit is the limit of the root, which is equal to n all over root, where n2 is a positive what integer. These are the laws. I know you'll be saying, how am I going to learn all these laws? Very simple. Leave these things. It is an enemy that is in the boat. You're going to understand limit. Now, if you say you have understand introduction of limit, you say the limit f of l, the limit L is the value of f of s as s approaches a, and we'll talk about the 7 laws. The sum of limit is the limit of the sum, the difference of limit is the limit of the difference, the product of the limit is the limit of the product, the quotient of the limit is the constant of the limit is the limit of the constant, quotient is the quotient of the limit, power is the power of the limit, and root is the root of the limit. Quickly now, let's now learn the types of limit. Now, there are practically 9 types of limits. Number 1, we have what to call the normal limit. Number 2, we have what to call the limit at infinity. Number 3, we have what to call the sub limit. Number 4, we'll talk about your epsilon delta limit. We're going to discuss all this. Number 5, we'll talk about the trigonometry limit. And number 6, we'll go further, talk about your right and your left limit. And we'll talk about your logarithm limit, we'll talk about exponential limit. And number 9, we'll talk about limit at continuity, the one we call your continuous limit. These are the type of limit, and each of them will own one class. So this is everything about introduction. Next, now we are going to talk about your limits under your normal limit. But before we talk about that, 2 things to note. Number 1, take note that in math we say you cannot have any t over 0. It will give you infinity or math error. Any t over 0 will give you infinity or math error. Or you have negative in a square root, it will give you math error. But you are permitted to have 0 over 3. 0 over 3 is 0. But you cannot have 3 over 0. It will give you infinity. Those are the things to note. Now, if you say you understand it practically now, let's now move by talking about our normal limit, which we are going to discuss in our lesson 2. See you in that class. This is just introduction. Peace out. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.